Hey guys, Paradoxio here. Welcome back to a brand new video, everyone. Today we are going to be learning Dunder methods in Python objects. Now, Dunder methods are a very important concept that every Python developer should know when it comes to object-oriented programming. Basically, what these Dunder methods allow us to do with our objects is we can perform very many different operations on them, whether it's arithmetic-based operations, or if we're checking for things like equality, inequality, greater than or less than, or even just simply representing our object in different ways. To get started, I am going to go ahead and head over to another file that I have, where I'm going to create our object for today's video. Now, the code in this file already doesn't really matter. You'll notice I'm not really showing it. It's just a project I've been working on myself, but I thought it would be perfect to store this object that we're going to make for our example in this video, which is going to be a point. Now, if you guys have taken a math class in high school or college even, you may be aware on what a point is. It's that thing on a graph, have two of them, you can connect them and form a line. You know, those fancy things with X and Y values. Well, that's pretty much what we're going to be using for today's example. So let's create a class called point. And I'm going to pass in the object type here. And then we are going to create our constructor, which, by the way, if you didn't know, that is actually a Dunder method. So if you think you've never used them before, you may have actually used them if you are creating objects often. So def underscore init underscore, and then pass in self and an X, and type hinting this is optional. Now, in case you guys didn't know, how it gets the name Dunder method is because we have double underscores encapsulating the method name, hence the name Dunder, double under. So that's where the name comes from. But here, we're just going to type in self.x is equal to x, self.y is equal to y. And if you need to perform any kind of data validation here, feel free to do so. But this is basically all we really need to go ahead and import it into our other file. So from main, import point. We're going to create a new instance of point. Give it an x value of 2, y value of 5. And if I go ahead and try and print p, our variable storing the instance of points, you'll notice that we get this weird message or output in our terminal or console. Main.point object at 0x00000015b0aba7e00. What is that? Well, that's actually the memory address where our object is stored. Now, if you're doing anything low level, then, well, this is probably important to you to some extent. However, Python is predominantly a high-level programming language, and we don't often have to worry about memory addresses whenever we're programming in Python. So whenever we print out an object to represent it in our console, this is not what we are expecting. This is not what we want to see. So we're going to create a Dunder method that simply represents our object in a human-readable format, so that way we can use it for things like debugging purposes or just simply displaying the object's contents like attributes and even behaviors on the screen. So let's get started. Def under repr, R-E-P-R, under. And we're going to pass in self. Now, what is this? This is known as the repr Dunder method, and it's going to allow us to represent our object in a way where we can make debugging a little bit easier. And all this really does is it's going to return a string. And it's going to look something like this traditionally. And if I come up here and print P again, or just run this code, we now see our actual object. And this looks exactly how we would write it in our code. And we use this for debugging purposes. So if you ever need to know what's going on with your object, what attributes or properties it has, then, well, we would use repr to show what's going on in that object, what's in the arguments for our properties and such. And we can also achieve the same thing by typing in print repr and then setting p as the argument, and we get the same output. Now, there's another way we can represent our object in a more human readable format, and that is the Dunder string method, which is typed just like this. Remember, we are dealing with double underscores, not singles. And we're going to return a string again, but this time we're going to return it in a way that we can actually understand it, because the usual user of our object may not understand just 0.2, 5, but what they might understand is point at x is equal to, and y is equal to self.y. So now if I change this to str instead of repr and I print this, now anyone else who may not be as experienced in programming can look at this and say, oh, okay, this is supposed to be a point that's on a graph. So we can use the string Dunder method to sort of represent our object in a way that anyone can really understand. Now, of course, we don't have to wrap this in str or string. We could just print p like that and we'll get the same output. Now, another reason why you would need one of these two is because we actually do need them in order to run any other Dunder method for this object, like addition and subtraction, equality, etc. But speaking of, let's get into those real quick. So we can perform arithmetic with our objects. Now, when it comes to points on a graph, you may know that adding 2 points together will result in a point combined of the 2 preceding points. Well, we can achieve something like this in Python by typing in def dunder add dunder self other, and this is optional, but I'm going to type hint it as a point, so that way in case anyone happens to use this object, they will understand what's meant to be in this other placeholder. And since we're going to get a new point combined of the preceding two, we're going to have our return type as point here. And all we have to do is just type in return point self.x plus other.x and self.y plus other.y. And that's simple. We can also do the same thing with subtraction by just copying and pasting this, changing this to sub, and then simply changing the operators. And now, let's say I want to change this to P1 actually real quick, and then make another point called P2. And this one's going to be 3, 4. Now, just in our head, let's do the math real quick so that way we know what to expect. So 2 plus 3, that's going to be 5. 5 plus 4, that's going to be 9. So our new point should be 5, 9. So new point is equal to P1 plus P2. And we can print new point out. And now we get point at x equals 5, y equals 9. And let's wrap this in a repr so we can see it in the way that we would have written it out in Python. Sorry, I'm stumbling on my words. But as you can see, now we have 0.5, 9. Let's go ahead and subtract these. So 2 minus 3, that's -1. 5 minus 4, that's 1. So we should see -1, 1. And let's see if we get that, and we do. And remember, this is a new point. So if I wanted to, I could just go ahead and add a new point here as well. 5, 5 for an example. So 2 minus 3, -1. 5 minus 4, 1. So new point is -1, 1. Plus 5, so that would be 4, 6. And as you can see, we get our new point object, 4, 6. Pretty neat. Now, let's talk about the multiplication and division Dunder methods. Now, those are a little bit different. Instead of multiplying by another point, which you could do if you want, we could also just have a magnitude. So, def, mul, self, other, I'm sorry, not other, but magnitude, which is going to be a float. And we're going to get a brand new point. Return point self.x times magnitude self.y times magnitude. Now, of course, if you weren't dealing with a point and maybe dealing with something else, you could also just, like if you're using other here for an example, you could do self.x times other.x and then self.y times other.y. But I'm just going to use magnitude for this example. And we would do the same thing for division. It's just dunder, div, dunder. And we would change the operators from an asterisk to a slash. But that's pretty neat. Now, what did I do wrong here? Looks like I messed something up. Oh, whoops. I forgot to add the asterisks back. All right, so we have a new point here. Or, I'm sorry, P1. But I want to multiply the x and y values of P1 by 3. So we can do P1 times 3. Now this will be, x will be 5, and then y will be 15. So we should see 5, 15, or, which, I'm sorry, 6, 15. I was thinking of addition there. So now we have 6, 15 here, by simply multiplying our object by a magnitude. Pretty neat. Now, lastly, we're going to talk about the equality Dunder method. And there's more than just that. There's the inequality Dunder method. There's also Dunder methods for checking if one object is greater than the other, less than the other, etc. There's actually a lot of Dunder methods we can use. I definitely recommend you guys check out Python's documentation to get some inspiration on what Dunder methods we should add to all of our objects. But last one here, Dunder EQ Dunder. And this is going to check if it's equal to another object of point. And this is going to return a Boolean value, so true or false. And it's done like this. So, in this equality check here, we're checking if the x and y values of both of our respective points are equal. So if the x value of 0.1 is equal to the x value of 0.2, and the y value of 0.1 is equal to the y value of 0.2, then we're going to return true, otherwise false. So let's come back here, make a brand new point. And we're going to make this point 1, 3. And then in here, in this print statement, I will type in P1 double equal P2. And as you can see, in our outputs, we receive false. And that's because the x and y values of this point are not the same. Let's try 2. Since now we have equal x values, we're still going to get false just because our y values are not equal. But let's change this 3 to a 5, and now we receive true in the output. So that's how we could set up some comparisons for other points. Now, of course, like I said, there's a lot more than just these Dunder methods. I highly advise you guys check out Python's documentation. They have a lot of information on Dunder methods and the different kinds of Dunder methods you can implement into your objects. But that's it for today's video. Thank you guys so much for watching. If you have enjoyed this tutorial and would like to see more just like it, be sure to let me know in the comments. Let me know what you would like to see. Leave a like, subscribe, and also don't forget to join my Discord server and create yourself a free account on houseofcode.xyz, so that way you guys have access to sharing your code files and projects to the internet. But that's everything for today, and you all have a wonderful night. Goodbye, guys.